Welcome back, guys. I'm Andrew, and today we are going to go over the basics of Onshape. And essentially, this is for the AEC Applied Engineering Club for Fullerton College. That's where I'm situated in, and we are working on our startup project, which is basically a telemanipulator, which is a fancy way of saying a robotic arm. The reason why we're gonna go with Onshape for this project is because it's free, it's browser based, which means that anyone can access it from pretty much anywhere. And you're able to collaborate among, I don't know if there's a limit, but you can collaborate with a lot of users, as you'll see later. So when you're creating something, you can either create a folder. So if you want to like organize, so like test, you can create a folder. If you want to, you can import different files. Um, like I don't like other 3D design files like step, STL, all this other stuff. But for now, we're just gonna go straight into design. So when we create, we're gonna create a document. We can rename it as like test, or in this case, I'm in charge of the claw, so I'll just do claw, and then we'll just create a document. And keep in mind that all documents are public, regardless if like you edit your permissions, or if you're subscribed to like a premium account. But if you're not, you have a free account, which most of us should have, then all documents will be public. However, only selected people that you choose can edit on it. Okay, so over here we have what is called our part studio. If you're I'm just gonna talk in the sense of that we're gonna use a mouse, so no trackpads, no nothing. So you can, if you want to highlight, you can left click and drag. You can click things, left click, the easy stuff. If you want to rotate, you can either use arrow keys, or you can use this little box over here that's in the top right corner that also allows you to move. The best way to move around freely is just to hold right click, and then yeah, you can go whatever you want. You can use your scroll wheel to zoom in and zoom out. And yeah, that's pretty much like how to navigate your parts if on a part studio. So for now, we're just gonna click this corner because this is the default view. And let's say we want to make a cube, right? So we're gonna click on a face. There's a front face, there's a right face, and there's a top face. For now, we're just gonna click on a top face, and then we're going to press sketch. And then you can use right click and drag to like try to, I don't know, reorient your point of view so that it's focused on just the top. Or you can click on a face on the cube over here and it'll take you to it. So if you want to do front, you'll click the front, right, bottom, and so on. So we want the top. And as you go on, you'll probably discover like some shortcuts. So like for example, you can press N and it'll immediately take you to the top down POV. So we're going to make a cube. But first, we want to think in 2D. So think of this sketch as like we're trying to make shapes in 2D. So if you're like into Google Slides, you like making shapes, text boxes, it's pretty much the same thing. So over here, there's a lot of different options. If we want to make a cube or just a rectangular prism in general, we're going to want to look at this corner rectangle. And if you go to this arrow, you'll see there's different options. You could go from corner to corner, which is like exactly what it is, corner to corner. There's center point, which you pick a center and then you drag, and it's all based off the center. And the last one is an aligned triangle. If you want to make a triangle that's not exactly 90 degrees, but you want to angle it, then you can also do the same. For now, let's do a center point, and then we're just gonna drag here. And if we want to give our design some dimension, because right now it's freely dimension, which means you can make it any size, any shape you want. Let's say I want to constrain this to let's see, what's the workspace units is in inches. So let's say we want to confine this rectangle so that it is 2 by 3. So what we're gonna do is we're gonna click over here, dimension, and again there's a little parentheses, or it's a bracket. I'm not too sure. It's kind of small, but there's a parentheses and there's a shortcut is the letter D. So you can either press this and you can do your dimension, or you can just press D in dimension. And we want to make it 2 by 3. So then we're gonna type 2 inches and it'll immediately constrain it. And as you see, we cannot move it up, and we cannot increase the height of it, but we can still increase the width because we haven't constrained it to a dimension. So let's do that. We want it 2 by 3, so that's gonna be 3. And now chances are you probably are in light mode, which I kind of hate, but it's okay. So let's go back to the unconstrained rectangle. Unconstrained edges and corners are typically represented by like a dark bluish color, and then once you constrain it, then it should be black. And then if you're in dark mode, because dark mode is obviously better, again the bluish hue for unconstrained, but this time if it's all white then it's constrained. So because our rectangle is completely white, it tells us that it's a set sketch and it's not going anywhere and it's fully constrained. You want to try your best to fully constrain your shapes. It's just proper technique, but that doesn't mean that you can't make 3D shapes with unconstrained 2D surfaces. So we're done with our rectangle, and now we want to turn it into 3D. So think of it as this rectangle as like a piece of paper, and you're extruding it by repeatedly adding layers and layers and layers of papers until it looks like a rectangle. That's kind of like what we're doing. You can think of it that way. So what we want to do is we want to press extrude. Extrude is basically we're taking a face and then we're turning it 3D, like linearly. So we're gonna press extrude, and then it's asking us to select a face or sketch region to extrude. So we want to select our face. This is called our face now, and it's gonna automatically tell us to extrude it. And you can see that while I am dragging the height or determining the height of this box like 3D structure, you can see that over here it's also changing based off what I'm setting it. So you can drag it to see what you want, or if you want to be more specific, you can choose a certain height. Let's say I want it to be 2 inches. So now it's constrained. We're going to click done, and then we have our extruded box. And then if you want to, like, let's say you want to add more 3D shapes to this box, we're gonna go back to what we talked about on clicking a plane and then pressing sketch. But you don't necessarily have to do only the front, top, or the right plane. You can choose any plane in existence. And when we extruded this box, we ended up creating 6 different planes, one for each box, or one for each face of the box. So if we want to say, let's put a circle in the middle of this box here, we're going to click on this face and we're going to do sketch. Then we're going to reorient our POV, and then let's make a circle. So the circle, there's many ways to make circles. The easiest one is probably this one: center point circle, 3-point circle, and then an ellipse for ovals and all that other stuff. So I'm going to press center point circle, and one thing about Onshape is that it automatically has like midpoints and corners defined. So if you wanted to lock onto a specific center point, I'm going to align my cursor until it hits that midpoint right here. And you see that as I drag my cursor, as long as it's close to it, it's going to tell you, oh, you want the center of the circle to be, I guess, in line with the midpoint that you selected over here. So I'm going to do that over here and over here. So this midpoint right here and this midpoint right here, until eventually you see that those two line up. Then once I click, this is Onshape telling me that this circle is perfectly in the center. So let's just do a random, I guess just like any random length, because we're going to dimension it anyway. So when we dimension it, it's going to measure by its diameter. So let's say we want a diameter of 1.5 inches. We're going to hit done, and then we're going to want to extrude it again. So same thing again, we're going to click on the sketch that we want, we're going to extrude it, and then we can adjust the size or adjust the height of it. So let's say 1 inch. We're going to press done, and then there is our simple shape, a box with a cylinder poking out of it. And I know this all sounds really simple already, but there is a lot of things you can do with just making boxes and cylinders. There's a lot of different shapes you can make. Let's see. There is a Revolve feature. Okay, let's work on Revolve. So revolving these is basically you're taking a face and then you're revolving it around some kind of axis. But we do have to define our own axis first. And axes are usually straight lines. So lines like this is an axis, this is an axis, over here is also an axis. But let's say we want to revolve a circle starting from this point of the box to this point of the box. So in order to do that, what we are going to do is we're going to select our face, and we want to let's see, we want to be a perfect circle, so we don't want to necessarily have it start here and have it start here, but more so we'll have it start in the front, because we know this front plane is perfectly cutting this box in half. So yeah, let's start there. So we're going to do sketch, and then we're going to go on front because that's like the most 2D perspective we're going to be able to have. And then let's say we want our center point to be, so over here. So yeah, at first glance it doesn't look like this circle is perfectly centered with this box, and for some reason it's not allowing us to snap, but it's doing that because when you see it, we're not exactly on the same plane as this face over here, so there's nothing to constrain. So in order to do that, we're going to force our own constraints on there, and that's where all of these tools come into play. Specifically because we want this circle to be at in the middle of this rectangle face, we're going to choose the midpoint, and then once we click it, what we're going to want to do is we're going to want to click this, and we want it to align it with the midpoint of this edge over here. And it's already doing that because it's already aligned with this. So next we're going to do the midpoint again. We're going to click the center of the circle, and this time we want to align it horizontally. Oh, right. Oh, wait, hold on. It's not on the same plane. Okay, we have to do some things first. So you can only constrain things that are on the same plane in most cases. So in order to do that, we're going to make a line to like mark our spot. So let's see. Let's make a line from here to here. And as you can see, when my cursor gets very close to making a straight line, Onshape will just automatically do it for us. And then this line is one of those lines that like will never end no matter how much you do it. So if we want to just do one line and just leave it so, we're just gonna do the line, and then once we finish and clicking it, then we're just gonna hit escape. And like that. Now the thing about this line is we just want it as a marker, but right now this line is like physically in our plane, which means that it can be manipulated, and that's something we do not want. So in order to do that, we're just gonna make it into a construction line. So now it's there, it's like there as a marking, and but it doesn't really exist for us to manipulate. So there are a few ways to do this. I think you can do this, and this is it pierce work? Some of these cannot be used. Okay. So what we can do is we can select one of our tools here, and specifically we want to use our coincident tool. And what this is going to do is it's going to snap our point with any other point that exists, or any line, and it will automatically be connected or in parallel with it. So in this case, we want to snap it to this line, and this is one of the cases where coincident does work outside of the plane. So we're gonna do that, and you see it snaps perfectly. We're gonna do the same thing with this one. So coincident, point and point, and like that. So that now once we drag our circle, you'll see that it will want to snap into the midpoint of this construction line. So we're gonna do that. Let's give our circle a dimension of 1 inch. And then we need to also define our axis, because we want to revolve it around some axis. We can't just revolve it out around nothing. So we're going to do another line and make a construction. And you can see that you can use certain lines or certain points as guides. So like in this case, this line indicates that it's perfectly horizontal in line with the construction line over here. And this is perfectly vertical. So we're going to do that. And you can do the same thing here too. So now we know that this line is perfectly parallel, and it's also perfectly like dimensioned as the same as this line. We're going to turn that into construction so that it doesn't become something that we can manipulate. And then we can determine like the height between here by dimensioning. So we're going to dimension, we can click this, and then it will give us our dimension. And you'll see later that this is actually going to be the radius of our, I guess, our revolution that we're going to make. So let's give it a radius of 2. And we're just going to click done. So after that, we're going to want to revolve it. So what we're going to do is we're going to click on the face, and then we're going to press revolve. And it's now saying that our revolve axis is red because there is no axis to revolve around. So we're going to press on that, and then we're going to choose an axis. We can choose this one. We can choose this one. There's a lot of axes we can choose from. That one we can't because it's not like the dimensions. It's not like in line with the circle that we want to revolve. In this case, we're going to use this axis that we created ourselves. And yeah, that's pretty much it. Another cool thing about like this extrusion is that you can choose to add to a part, or you can make it become a different new part. So if we want to make it a new part, then this just becomes a surface, and this part is its own separate thing. But we want it to be the same thing. So we're going to go back to revolve, and then we're going to press add, and it's going to add to Make sure that it says solid, because that's gonna give you the part, not the surface or thin. So yeah, we're gonna click our face. If your face isn't accessible, you can choose to hide your part so that you can press it. So you see before it's hard to press because my part is in the way. So I'm going to hide it so I can click the face. I'm gonna unhide the part and I'm gonna press add. And it's asking where do we want to merge it to? We want to merge it to part 1. So you can either click this or you can click the face, or not the face. You can click the physical part that you want to add to. So we're going to do that. We're going to click done. And now you have, I don't know what I want to call this, like just some part, because we're just having fun right now. So we have this, and then yeah, that's pretty much it. Let's go over assembly. Assembly is going to be really important because in the end when we're done CADing, we're going to want to put all our designs together into one piece. So assembly tabs, Onshape will automatically create an assembly tab, or you can choose to have multiple assemblies and by clicking the plus and then inserting tabs. There are some things you can do, like there's applications in which you have to go to the App Store over here. There's a material library, feature studio. There's a CAM PCB and render studio, but those require premium upgrades. We're just going to focus on these. Specifically, we're going to do a lot of part studios, assemblies, and drawings. But for now, we're going to do the assembly, which Onshape already gave us. So to insert a part into our assembly, we're going to go to insert. That's all the way in the top left corner. And it's going to give us a list of assemblies. You can get it from your current document. You can go from other documents that this one is from the public workspace, but this is what you should see. So when you go to other documents, you can go to documents that you already own, recently opened, created by me, shared by me, or shared with me, and then there's a public open source I guess yeah, just open source web. We're gonna go to the one owned by us. Sorry, we're gonna go to the current document and then we're just gonna click our part and then we're just gonna put it down. So now it's a part in space. You can drag it along, you can rotate it. To rotate it freely, you want to click on it once and then you have a bunch of these arrows and shapes. This arrow means that you're only moving it upwards and downwards, left and right, and then forward and back. The square means that it's kind of like the same thing, but it's only bound by the plane that these two arrows make. So it's only moving here. You notice that it's not moving forward and backwards. Same thing with the other ones. And then you have these things above your arrows where you can choose to rotate your part. So let's say I want to rotate it this way. I want to rotate it like 90 degrees. Now I want to rotate this way about like 180 degrees and so on. Okay, let's just reset. All right. If we want our part not to move, we can right click it and then just go to fix. And this is going to fix our part in place so that it's unmovable in space. Okay. Let's go over what all the mates that you can do in assemblies. I'm not going to use this test. I'm going to go back to one of my other documents because I think I'll have a better example of it. Okay, so let's say for example, Okay, let's do this one. So this was a design of an airplane launcher that I made back in senior year of high school for a robotics competition. And basically what it is I designed all of these pieces of, or like sheets of plywood. We laser cut them and then we assembled it. But it's good practice to assemble it before, or to assemble it on your CAD before you assemble it like in person. You can see that there are a couple of fastens over here. So let's quickly take this apart. So again, this is like an airplane launcher. It's made specifically as a 3D print. So first thing we want to do is we're going to fix this in space, and then this is where we're going to probably do a lot of servo attaching in Onshape. And I know that in our robotic arm design, we're gonna have a lot of servos. So it's good to, I guess, try to learn how to attach servos to certain parts in Onshape in an assembly. So in this case, our first mate is going to be the Fastened mate. It's simple, it's pretty easy. You just take a point of a part and then you fasten it to another point on the part. So this is what it looks like. We're going to fasten, and then remember I'm using right click so then I can rotate in space. It's really intuitive. I'm going to click. You see that as I hover over this servo block over here, you're going to see a bunch of like face happen, and then you see like these like circles here. The circles represent like, oh, this is a mate connector. Mate connectors are basically places where you can connect mates to other mates, and every block in Onshape has its own mate connector. So over here, we want to align this screw hole with this screw hole over here, so that once we put a screw in there, it'll fasten the servo to place. So we're going to click this face over here, and I know that it can be really weird whenever you move your mouse, like, oh, I don't know which points I want to click. So like I'm trying to click this one, but then like I move my mouse a little bit and automatically it changes into a new mate connector. So what you can do is you can hold shift and it will lock it into place. So before, like, it's going crazy, but once I click shift, then it's only constrained to whatever face or whatever points are on this face over here. So let's click this one, and then we're going to fasten it to this hole over here and click yes. So now this servo is correctly fastened on here, and it took a lot of designing and dimensions, but you'll see that all the other holes here are perfectly flexed with the servo. So that's good. And then next, what we want to do is, here, I'll delete this at 1.5. I'm going to attach this servo gear into the driver over here. In practice, or like in real life, you're not going to need to do this because it's already going to be on the servo, but then in the CAD, we need to define it. And to do that, we're going to use a Revolve or a Revolute mate. A Revolute mate, basically, it constrains a part to a face, but now it has free rotation. So we're going to do this. We're going to go here. We're going to hold our shift, and then we're going to click the center of this face. And then we're going to constrain it over here. And then don't worry about the offset. I'm only doing this because it's more accurate. So yeah, once we do that, press yes. Now this servo gear is now constrained to the face of the driver, but instead of being completely fastened, it has now free rotation, which is good because servos need to rotate. Otherwise, what's the point of having a servo? So let's go ahead and finish this part. We're going to fasten the top of this servo horn and we're gonna fasten it to the face of this face. Oh, that's wrong. Okay, this should have been over here. There, that's better. So yeah, the issue I had earlier was that when I rotated this, you can see that this part kind of just goes into the other part, which technically shouldn't happen. And this is one thing that as far as I know, Onshape does not have compared to Inventor and SolidWorks, is that it has no collision detection. At least as far as I know, it has no collision detection, which kind of sucks. But for now, we're just gonna have to deal with it. So let's go back to, let's refasten this servo a different way so that it doesn't just phase through the part. And then let's fasten it one more time. And the thing about fastening is that if you don't have if the fastened isn't right, then you can choose to rotate it. So like in this case, that doesn't look right because the screw holes aren't lining up. It still rotates, it still works like it's intended, but we're not actually going to build it like this, right? So we're going to go back to our fasten, and we can choose to reorient your axis so that it's fastened in a different orientation. And you could do this further by offset or rotating it, but for now it's okay what it is. So we're going to do that, and now it works. So it's designed as the way it's supposed to. The servo goes back and forth. You can choose to animate this servo by going to the Revolve, right clicking, and then animate. You could choose to go a little faster. You can do reciprocate. Typically servos are 180 degrees, so you want to go from 0 to 180. And the steps include how slow or fast. The less steps, the faster it is. So we want to do, like, let's say 30. And then go. So yeah, we just animated a servo. And later, as you learn more, you'll put a lot more fastens together, and then you end up getting let's see, what's an example? You'll end up getting stuff like this where, I don't know if it'll take a while to load because this is a pretty big project, but yeah, when you start assembling more and more robots using Onshape, you're going to do a lot of fastens. You're going to have a huge list of parts because of how much stuff there is. Like over here, this list takes into account most of the screws and everything. And yeah, you'll see that parts over here, there's a lot of fastens. If I choose to reveal all the fastens together, or all the mates together, like you can see that here's a group mate over here, the origins over here. So if I choose to show all the mates, you'll see just how much mates there are. There's a mate over here, there's a mate over here, there's a mate over here. There's just a bunch of fastened mates. And okay, you can also animate some robots to also move as well. So let's just take this robot as an example that I made just for fun. And look at the list of how many fastens and revolutes and other kinds of different mates that we have. The list goes on and on. It can be pretty hard to manage because I don't normally rename all of my mates. It might be good practice too, but I think the time you save by doing it, it's not really worth it. Or the effort you save it by doing it is not worth the time. So yeah, look at this robot. It has wheels. These are called Megnum wheels because when you program them independently with the motor, you can program it so that they can move, just like they can move and rotate in different ways that you didn't know like could work. So you can see that here is an electrical motor here. Here is like 1, 2, 3, 4 servos. And they're attached to this linear slide. This is like a drawer slide. And if you do the animations correctly, oh, it's fixed. If you do the animations correctly, it will slide like it's intended. So like you can imagine programming this servo and this servo to rotate a certain distance so that this drawer size can extend to its full length. So I'll just play it slowly. You can program how fast the servo goes. You can program how much it can rotate. And yeah, like that. There's servos here too. And yeah, there's a lot of stuff you can do with assembling. The slides, you can apply what we call, it was like either a planar mate or a slider mate. I forgot which one I used. It was probably the planar one. Planar one is more, it's more what's the term? Not flexible, but more, there's just more freedom that comes with it. So yeah, the slides, the linear slides, that it comes all the way up and it goes back down like this. And all of that is possible because we have these motors here that transmit rotational motion into linear motion. And yeah, it's just a lot of building, but you can see that as I extend the slides up and down, the motor, the gears and the belts on the motors over here and the axle, they also move with it. Okay, yeah, that's pretty much all that I have right now. Yeah, it's very basic. I think Onshape, it's something that is better learned by yourself rather than having like an instructor do it. And at the same time, it's also like it can be pretty fun trying to learn how to do CAD by yourself. All of this stuff over here, I would say is like 10% my engineering teacher taught me and 90% what I learned on myself, going online, just trying to do it by myself, and also just talking with people who already know and seeing like what techniques they have or like what stuff they can offer. So you can see that there are some like custom design parts I have over here. And if you notice, like this is really just a rectangle that we probably like curved out the edges, we poked some holes in it, but it's really that simple. And it just goes back to what I said about how you can make a lot of different complex looking shapes just by making rectangles and cylinders and just putting them in together. So yeah, that's about it for me. Yeah, that's pretty much about it. And I don't want this recording to go too long because it'll take a lot of storage on my computer. But I'll upload it. I'll make sure everyone else also has a chance to look through it.